Hi and welcome to another instrument choice support video. In this video we'll show you how to take a relative humidity measurement using the IC 736700 sling psychrometer. To do this you'll need the relative humidity table. This comes with the meter, an example is linked in the video description, and some water, we're using distilled. To start, the reservoir will need to be filled with water. It's probably best to perform this outside or over a sink to avoid making a mess. Once filled and the wick is sufficiently wet, close the reservoir chamber lid. It's time to take a measurement. Whirl the psychrometer rapidly for around 20 seconds. After 20 seconds or more has elapsed, record the wet and dry bulb temperatures immediately. Here we've recorded 22 degrees for the dry bulb and 16 degrees Celsius for the wet bulb. To calculate our relative humidity, we need to determine the wet bulb depression value. To do this, simply subtract the wet bulb reading from the dry bulb reading. So in this instance, we will subtract 16 from 22. Our wet bulb depression is 6 degrees Celsius. Now, using the chart, we'll follow along the top row to find our dry bulb temperature of 22 degrees. Then find the wet bulb depression value on the vertical row, 6. Triangulate the two readings to determine the relative humidity value. In this instance, the outdoor humidity today has been measured at 54%. To summarise this chart, the dry bulb temperature is taken directly from the dry bulb thermometer, and the depression of the wet bulb is the dry bulb reading minus the wet bulb measured reading. For more information on this psychrometer, including a written step-by-step guide on how to take measurements, see the links in the video description. We hope that you found this video helpful. Thanks for watching!
This is used to measure lighting levels. This tool measures lux. A reading of 1 lux is equal to 1 lumen per square metre. A lux meter is a common tool for electricians, shop fitters and energy auditors. This lux meter is very simple to use. Just hold the sensor in a horizontal position in the area that you wish to measure. Next, select the measurement range. For low levels of light, select the range up to 2000 lux. For medium levels of light, set the range up to 20,000 lux. For very high levels of light, select the range up to 100,000 lux. Notice the measurement changing as I move the sensor around, and increasing as I get closer to sources of light.
GPS isn't just a feature on your iPhone or an inbuilt service in your car. It's actually the entire system of up to 30 satellites that were put into orbit by the US government to assist us in determining exactly where we are on Earth. GPS relies on the visibility of at least 4 satellites in the sky at all times from any position on Earth. The calculation of where exactly you are on Earth, as well as what altitude you're at, relies on the mathematical principle of trilateration, which is similar to the concept of triangulation, a process that allows you to determine the position of a point based on its relationship to the other points in space. You can calculate the distance between yourself and any satellite by comparing the time delay between a radio signal sent by the satellite and the receiver. Because we know radio waves travel at the speed of light, we can calculate the distance from the satellite based on time. Once we have known distances from a point on Earth to 3 or more satellites, we can find the exact point of intersection of all of the spheres of possible distances from all of the satellites. This position is our position on Earth. You might be surprised to learn that GPS, the Global Positioning System, has been around in one form or another since 1973. In the 1990s, the US military was frightened of the idea of adversaries using GPS for ill, so they made it a public resource and purposefully degraded the signal.
In this video, I'll demonstrate how to measure the height of a tree using a clinometer. So, another important dimension of a tree is its height. It's important to know the height because when you put the diameter and the height together, we can tell you how much wood is in that tree. That's how we classify their size. So, to use, we have a tool to use to measure the height of the tree, and this is called a clinometer. Clinometer uses trigonometry to measure the height of a tree. And if you remember back to your high school trig, maybe or maybe not, if you have a triangle and you know the length of one side and the angle, then you can understand the length of the other. In this case, that's the height of the tree. But since we don't want to have to do a lot of math, my instrument is already calibrated as long as I stand a known distance from the tree. So since my tree seemed pretty short, I chose the 66-foot scale. I could have chosen 100 if it was a taller tree. I'm going to look at the tree using my clinometer. I have both eyes open, and I look at the scale. On mine, it's on the right, the 66-foot scale. I shoot the bottom of the tree. I have both eyes open so I can put the black center line at the bottom of the tree. I read the number 7, and then I'm going to swing it up to the top of the tree and see the top of the tree. I'm looking at it with my left eye, and with my right eye I'm reading the scale and I see the number 42. Since I've gone past 0, I have 2 angles, 0 to 7, 0 to 42. That means to get the entire distance I have to add them together, or 49. So using this instrument, that tree is 49 feet tall. When you look through the clinometer, you'll see 2 different scales on the right and the left. To check which scale you want to use, tilt your head way back while looking through it to see the unit label at the bottom. On most clinometers, there'll be a percent side and a chain side. To use the percent side, you'll want to be 100 feet from the tree, but 50 or 200 feet away can also work. To use the chain side, you'll want to be 66 feet from the tree, but 33 or 132 feet away can also work. To get an accurate reading, measure from the uphill side. For taller trees, move farther away. This is because the clinometer loses accuracy when tilted too far up. Clinometers are more accurate than the Biltmore stick demonstrated in part 1.